we are going to talk about web performance tonight and perception, speed perception, and the metrics. So we have a four-part talk for you today. The first part is just going to be a performance overview. Then we are going to talk about the visual metrics of speed index and perceived speed index. And then I'm going to go into a very brief, very deep dive on web apps and Lighthouse because I'm a masochist and decided to put that talk together yesterday. And then we're going to talk about the speed perception study, and we are doing number 2 of the study. So we have little cards if you guys can partake in the study. It's an open source study, and these are not business cards. They're actually just a link to the study. So where's Parvez? Here he is. He is the head of data science and machine learning at Instart Logic. He is brilliant, and the reason I tell you that he's brilliant is because it embarrasses him.
Yeah. This is Estelle. She seems to be very busy writing all kinds of books. There's a new one. Somehow still finds time to come to work, so that's pretty good.
So we're going to start off with an overview of what is performance, and I'm just going to go directly there. So all the slides are available at instartlogic.github.io. Instart Logic is where we work. GitHub, I don't know if you've ever heard of it. IO, and then a /p, and then /sfhtml5. That's the only part you have to remember. The other part is just the 4 parts of the talk, because kind of ironically, there is no performance done on this deck. But this deck is accessible for screen readers because that is actually important. Okay, so this part is what is performance, objective versus subjective metrics, and perceived performance. So if a site loads in 2 seconds, is that fast or is that slow? 2 seconds is slow? Does your site load faster than 2 seconds?
Hopefully, yes.
No, it does not. But if it is a hello world, it definitely is slow. How about in 18 seconds? Is that slow or fast? If it's Lord of the Rings trilogy and it downloads in 18 seconds, it's pretty fast. So what does fast and slow mean? If you tell me that your site loads in 5.2 seconds, which is faster than average, actually. Yeah, 2 seconds, sites do not load in 2 seconds. No, they don't. So if you say, like right here, I guess this is 6.2 seconds. If you say my site loaded in 6.2 seconds, which is where most people, and this is completely imaginary, I just made it up in SVG. But that is someone with your same network on your same day in your same location. If you're located somewhere else where it takes longer for the files to get there. So like what exactly is load time? Load time is different. There's no, my site loads in 2.3 seconds because I can promise you if I'm on 2G in Siberia, it is not loading in that same amount of time. So I'm going to play 2 videos and let me know which one you think is faster. Which one was faster? Left. So these are not actually fully loaded. Right? It wants to give me the dictionary. Hold on a second. Let me reload. And hit play again. So at 7.8 seconds, they both look fully loaded, but they're actually not. One takes longer than the other. So one has a metric that says it's faster, but the other one is perceived to be faster, right? So what do these metrics mean?
By the way, one point, if you thought it's the right, you're not wrong. There are people that perceive different things. That's the funny part.
Yeah, it's totally perception. And actually perception is what is the most important thing here. The metrics that we're measuring with, they're just metrics. They're objective metrics, but they're not measuring perception. So performance has to do with a lot of different things. It has to do with time to load, time until the site is usable, whether the site jumps up and down like the one on the left did, whether it's responsive to your touch, and whether it's smooth. The scrolling is smooth. So performance is many things, and it's different things to different people. So I'm not going to go over this talk because Paul Irish, I believe, gave this talk a year and a half ago, but if you want to look up Weyl, it basically suggests that there is an amount of time for each performant, and they call it Weyl, but it's actually liar. Because if you look at first the dark blue, then the light blue, then the green, then the yellow, so it's actually LIAR. But I hear that's not really good for marketing. But page load is 1 second, idle is 50 milliseconds, animation and scrolling is 16 milliseconds, and response to input is, what, 200 milliseconds? I don't actually remember because it's been a long time since 2015. So web performance has to do with the number of resources. It has to do with the time it takes to parse those above resources and to execute. So you first have to parse the JavaScript, and then you have to execute and paint. And then perceived performance is actually how the user perceives that. So we can have metrics for the above 3. We know how many bytes it is, how long it took, how slow the network is. But what did the users feel? So there are some blocking things, and we have so much to cover. That's why I'm going over this pretty fast. But I did want to just show this for 1 second, because there are all of these are metrics that we can actually use with the timing APIs, and we can measure exactly what those are. And I color-coded it so you can see if you're on a waterfall chart what those colors mean. That's what you're measuring, basically, and it goes down a little bit. So DOM content loaded should be instant, but on some sites I've actually found it to be 4 seconds. So you got really fast to load, but then you had a 4-second delay. So what I've been pointing out is that we have all of these objective metrics, but the perception of the user is really subjective. So here we have 2 videos, and the load time is almost identical, right? You're talking about less than 40 milliseconds, which is not noticeable to our eye. But visually complete is way off. So if you're measuring time to load versus visually complete, which one loads faster? Well, Staples just keeps on going and going and going, but some people perceived that it was actually fully loaded before the carousel started loading and before the ads came in. So that is user perception. So we have 16 seconds versus 8.7. And web page test, if you look here, you'll see that in this one, Staples is faster, but if you do visually complete, Staples, it was Wolferman's that was faster, now Staples. So the 4 different ones that I'm showing go back and forth as to which one's faster, depending on what metric. So if you're just trying to tell your engineering lead that your site is really improved, you just pick the metric that works best for you. But really, what is good user experience? So which one loads faster? The one above, this is a bullshit slide, I made it up. But which one loads faster, the top one or the bottom one? So the top one took longer to load, right? But if you were actually watching it, the bottom one would feel painful because nothing actually happened for 6 seconds. So that is a subjective feel. Because, like, let's say you're going to a restaurant. You wait an hour and they bring you the appetizer, the main course, and the dessert. You're kind of like, wow, this is a messed up restaurant. But let's say it downloads on time, right? But the JavaScript has not been parsed or executed, so you can't actually interact with the page. That's like going to the restaurant, getting your appetizer on time, getting your main course on time, and getting your dessert on time, and then after an hour they bring you the silverware. Like you could finally eat. So what we need to ask ourselves is, what is perceived performance and what should we be measuring? Does jitter affect what we feel about performance? If a modal pops up, do people feel that that makes the site go slower or not? And that is something that we've been studying, and we are going to cover our results that we found, but we're not sure if we found the right answer yet, because what we studied all had modals, and we don't know yet if that really impacts people's perception. Because really, some people, it's which one loaded first. Other people, it's which one stopped moving. So right now, the metrics are all measuring objective things, and we want to find out what metrics what objective metrics we can use to measure subjective perceived performance. But the main thing to take away from all of this part is, no matter what you do, the user experience is more important than the developer experience. So yes, you want to use frameworks because they're fun and they're great for your resume, right? But if you're sending something down the pipe that is using up all of the data, or if you're sending something down the pipe that takes 5 seconds to parse and execute, or even 2 seconds, because when they click and they can't get into that input field because you're still executing the JavaScript, and your virtual DOM has not matched up with your real DOM, that's developer experience over user experience. So I'm going to pass it over to Parvez to talk a little bit about speed index and perceptual speed index, which is a way of well, I'll let you explain it.
Okay, so let me give you a little bit of background about why I started caring about it. I am from a computer vision domain. I never worked in web performance before I came to Instart. And when I started working, we are supposed to be speeding up websites. I asked people, what does that mean? I asked 100 people, I get 100 answers. Nobody seemed to know what exactly it was. One problem, I think, was because it was genuinely difficult to articulate, because people had this opinion that every website is different. You can't think about these things similarly. But you see, people used to think about that, about recognizing faces or telling if there is a dog, these kinds of problems. And these are now done. And I have worked in groups where we did these kinds of work. So I became obsessed with trying to figure out if there is some set of things that are common across websites. Because if I give you 2 websites, so the example that Estelle was giving earlier is very instructive, right? If I ask you, is this person tall? It's hard to answer, but it's a lot easier to answer if I show 2 people and ask which one is taller. The relative, perceptually, it's a lot easier question. And one of the things that we discovered was that a lot of the people were questioning or reasoning about the loading or website speed by looking at a website, and it wasn't looked at in some kind of a relative fashion. And if you don't work in web performance field and you look at someone else, without a pairwise comparison, it was very difficult to answer, right? So we started to set up an experiment where we were trying to probe what exactly explains people's choices if I give you an A/B test. Like if I give you 2 websites, are there certain measures that I can take that essentially replicate what the person says? There are lots of metrics, as you saw the navigation API that Estelle showed. One that caught my eye was speed index that was done by Pat Meenan, who's ex-AOL, now works in Google person. He also invented... Oh.
I forgot to go to the next slide deck for you.
Okay. So he also built a webpage test. So those of you who use webpage tests are probably familiar with his work. And what I thought was interesting was that instead of looking at some timer saying some event happened here, other event happened here, he was at least reasoning about looking at the entire flow of, okay, how did the curve of loading happen? Now, why does this matter? So how many of you are comfortable with statistics? Okay, so I'm going to do a very quasi-lightweight statistic experiment on you.
Uh-oh.
Which is, so if there was this magical God-given website that essentially loads like that, and you tried 100 times and it loads every single time right on the dot, then what you would see is that the probability of loading would essentially be all at 0, right? You would have like a stick there, and it's 100% of the time at 0. And if you look at a cumulative distribution function, like essentially just integrate it, it will look like everything loaded here and there's a bar, okay? So I think what Pat was reasoning about in speed index was that he's looking at 2 websites that have visual progress, right? At every single, he's looking at difference between the frames. Blue loads this way, red loads this way. But based on the example I just gave you, if there was this magical website, it would load like this and just stay, right? All he's doing is measuring the distance between that area and these individual areas, and that's speed index. The equation basically explains the little intuition I just told you. And the area under curve is the shaded part, if you see, and it's the distance from this perfect website that you're somehow trying to get to. Now, one of the problems, so I'm a computer vision person. I'm looking at this equation and I'm like, what does the visual complete mean? And one of the things that caught my eye was that if you looked into the equations of how VC was computed, there was every single frame was converted into histograms of the pixel values, and histograms were compared. So if you're from my world, you know that this is problematic. I'm going to actually tell you why it's problematic, and that led us into a little rabbit hole. So when you are trying to reason about any scene, and you're comparing it with a different scene, and you're trying to make this comparison, and if you do it using histograms, what you're trying to capture is some kind of color similarity, or some kind of a object entity similarity, or some shape similarity, right? And if you are doing a visual completion using histogram, what I'm going to now show you are basically lots of pictures. They all have 50-50. It's a very simplified example where there are half a pixels white, half a pixels black, and you can see that essentially they all will have 0 pixel-wise similarity. So if you run speed index equation where you loop these images as a loop, it will have 0 speed index, right? You get what I'm trying to say? So you can construct this weirdo website that essentially loops these things, and it will have 0 speed index. The equation will give you 0. But you can see that it's all completely different. So the second point that you are usually trying to capture is that the first one, you should do this experiment on your own because it will be blatantly obvious. Try it.
Take your finger.
There's this famous saying in vision that eye is not a camera, right? There are a lot of other things that happen in your brain. The first one is a lot easier to explain. The second one is a very famous example from Ted Adelson's group in MIT, so A and B have exactly same pixel values, but your brain will never allow you to see it because it's assuming that there is a shade, which means that there has to be pixel-wise differences. Very famous paper in Nature. Now, this also tells you that if you just do, if I took a little bit of histogram from the top and the bottom and I compare them, in pixel space they would be 0, but you don't see them similarly, right? So the next thing that I wanted to basically, there is an object entity thing, we didn't include it. So what was very clear is that the equation basically was written in such a way that it was going to miss a lot of the things that are perceptually important. The thing that was especially important it was going to miss is that if some ad came and pushed the website over, or there is a jank going on and the website is jumping around, speed index wasn't going to catch it. So what we did is actually change how the visual completion was going to get computed. Instead of frame-by-frame histogram comparison, we used what's called structural similarity, which is not the perfect one, but it's a reasonable thing to do. All structural similarity is doing here is that, so the top left one is the original image. Comparison with itself, the mean histogram difference is 0, which is the original way speed index was calculating. And if you look at structural similarity, when it's exactly same, it will give you 1. And if they're really different, it will give you 0. And if you look through comparison with the top left image, you can see that your visual percept matches the SSIM numbers a lot better than it matches the mean histogram difference numbers. Right? Take a minute and just convince yourself that it's true. I'm not saying that it's actually perfect measure. We are actually working on improving these measures, but it's a very best of the class kind of a thing, very popular in the domain. So all we did essentially is to, like, Pat had open sourced his speed index code, so we started working on it, and we essentially swapped the computes with the structural similarity based computes, and we proposed what we called perceptual speed index. And basically, the idea is that, if you take a really good website like Etsy, this is 2015 screen grab of how Etsy loaded. It's a web page test result. It's a very nice, smoothly loading, fast website. In this case, the curves that are based on structural similarity difference and the mean histogram difference look the same. They're supposed to basically tell you that it's a fast website, right? And they match up. But if you look at some other websites, so this is Ralph Lauren in 2015, because that's when I started to dig into this. what you will see is that the red line, which is corresponding to mean histogram difference, basically says that mostly it's loaded, it has gone down the difference, whereas the green curve, which is doing structural similarity-based computation, is saying that there are still a lot of changes that are happening, right? It's capturing the carousel that's moving around, that essentially visually is very perceptible, and it's actually capturing that there is a big delta that's still happening. And you want that to be captured in your speed index. Like if the layout thrashing is happening in the website loading, your performance measure should say that something wrong is going on instead of saying that things are loading smoothly, right? And that was the simple idea. And we actually did very elaborate experiments on several hundred websites, presented to Pat, and we showed that structural speed index and PSI, perceptual speed index, are fairly linearly correlated, but they tend to differ quite a bit if there is this layout junk that happens. We also showed the results to Paul Irish a couple of years ago, and essentially that led to PSI being included in the Lighthouse, which is the gatekeeper for progressive web apps. So it's an interesting story where essentially someone from outside the web performance world was looking at how to characterize perceived performance, and we did some things that probably weren't familiar in the web performance space, but the community was open to actually including it in how things are measured. The things that I want to emphasize is that essentially PSI and SI are trying to do the same thing, except that PSI is trying to really also capture the visual jitter that happens from things moving up and down, and it's very sensitive to that. We don't think that it's the perfect measure, and we also don't think that it's the unicorn measure. I've data later that I will show you that there isn't one, but we have settled on a small set of measures that seem to be actually fairly representative of how people decide.
So here are a few resources if you want to look more into PSI and SI. But he brought up progressive web apps and Lighthouse, which is why I did the deep dive into it. Let's talk a little bit about progressive web apps. Who here has heard about progressive web apps? Who here has built a progressive web app? Awesome. Okay, so this is all old news, but for some it might be new news. So the general idea of a progressive web app is a web application that is progressively enhanced to be reliable, fast, and engaging, or it has to be reliable, fast, and engaging. And if it is, then it can become a progressive web app, and it can act like a native app on a mobile device. So the benefits are you can add it to home screen. Real benefit is you code it once because it is web, and therefore it works everywhere. You don't need to put it in the App Store because it is searchable. And also, once it is installed on the phone, it behaves like an app. So there's 12 of, I think, I didn't count them, progressive web app features. I can't go into all of them, but if you want to hang out on this website, there is a lot of information in here that actually goes deep into what each one of these means. But a few things like it's web technology. So it's not a plug-in technology. You're building these web apps not with CoffeeScript, although I guess you could and convert it over. But it's just basically the technology that you've been using for years to build websites. And let's pick a different one. Secure. So for something to be a web app, it has to be done over HTTPS. Let's go back to this. And you can get free certificates at Let's Encrypt, and I even wrote a blog post about how to put it onto cPanel because I couldn't find out how to do it on cPanel. So when I did, I wrote a blog post about it because I don't have anything else to do on Friday nights. Okay. So for April Fools, I created this website that did not go viral, though I totally think it should have. And so I decided to use that as an example, and this is what I'm going to talk about in terms of taking this site and creating a progressive web app. And just to get a little bit of chuckles, we have the blender, which is named Blend and Smooth, and Hoover Suck Deep, and Toasty McToastface. Okay. So to see whether it was a progressive web app and to help guide me in this process, I used Lighthouse. So Lighthouse is a test that is a browser extension. or not necessarily browser extension, can be in developer tools. I'll cover that in a second, which tests your PWA features, your performance, whether you're following best practices, and whether your site is accessible. Because if your site is not accessible, there's no reason to have it, because if 20% of the population can't access it, you're missing out on a huge chunk of the population. So, right now it is a Chrome extension, so you can get it in the Chrome store. If you have Chrome Canary installed, or in other words, the next time there's a release of Chrome, it will actually be in the developer tools under Audit. So you go to Audit, and the only thing under Audit right now is actually Lighthouse. And if you can also install it via the command line, and the command line instructions are right there. And for more information, you can either go to this deck, or you can go to the original source of parts of this deck, which is the Google page on it. Okay, so I tested my website, and I got 36, 76, 97, and 77. The reason I did so well on accessibility is because I always have accessibility in the back of my mind when I'm developing websites, and in the end, I don't have to put any extra effort into making my website accessible, because I was thinking about it when I was developing it. I highly recommend everyone do the same. So the two things that came up as accessibility, my deck has an unclosed div, and so it's going to misbehave for the rest of the day. But these are the checks it does, and the one thing I was sure I had done was forgot to declare a natural language, because I always forget to declare a natural language. But in fact, I had declared the natural language, and what I had forgotten to do was background and foreground colors have a sufficient contrast, which surprised me because that is something I think about. So what I had to do was fix these two things, and it turns out I had declared the natural language, but one of my colors was not enough of a contrast, and the part that it is right there. So if you go into Chrome Developer Tools, and then you inspect, and you go to colors, and it doesn't have colors anywhere, right there. If you have accessibility tools, it will actually give you a line that goes across, and it shows you, and I don't know why it's not showing up, because usually it does, but it's a live demo, and therefore it won't work. But it will show you what is AA or AAA. But I'm also a strong believer that you want to reach AA, but there are certain things that AA doesn't test. And so if you put a drop shadow, or if you have really large text, you want to go with AA or AAA, even better. But I'm pretty sure that that is fairly legible, but what I should do is put a dark gray screen behind it so that the image is darker, and then it will pop more. And I can be confident, even though it will probably never pass fully AA because of that little dot. But what it did make me think is, I didn't put a dark enough background color behind this image. If the image doesn't show up, then there definitely wasn't enough contrast, so I changed the color on that. Okay, enough on that. So that's accessibility. And next is best practices, and there's a slide in here, and I'm just going to go over to here and try to pick up a deck that is not broken. So close your eyes if you have a tendency for epileptic seizures, because I'm going to go through these really fast. Nope, it has a broken div somewhere. Okay. So best practices, here's the list of the things it goes through. And what it found for me is that I had 16 insecure, because I had it over HTTP2. That I had it over HTTP://. I'm not using HTTP2, and I don't have a manifest, so there is no short name. So to solve my problem of going to HTTP2, I work at a company that has a CDN that can go HTTP2, so I'm eventually going to put it back on there, and that's going to take care of that, because I don't know how to make my cPanel go as HTTP2 yet, but that might be a forthcoming blog pretty soon. In terms of the secure, what is going on? Okay, so in terms of security, I need to get an Ssl certificate. I got a free one from Let's Encrypt. Highly recommend everyone does it. It's really easy and simple, or not really that easy or that simple, or I wouldn't have had to write the blog post at the bottom of the page. But basically, there's 2 steps. You install it, but then you can't forget to actually redirect all your HTTP requests to HTTPS. So here's a little script for the htaccess file for that. So then I tested it for performance. And these are some of the things that it covers. It covers the metric of first meaningful paint, first interactive, first consistently interactive, and the consistently interactive is when it ends up being the same for all of my sites. But if you have an app that's pulling in tons of JavaScript asynchronously, it might not be the exact same. And that's okay, because if you're doing it in little chunks of 50 milliseconds and it reacts within 50 milliseconds, that's what you want to be doing. If you have tons of JavaScript coming in after load, you want it in small chunks. And it measures perceptual speed index, which is what we were talking about. And what's nice is it gives you the opportunities about what you can do and tells you where the critical request chain is, where you're failing. So when it came to my performance, I did okay, 76. Not horrible, but not where I want to be. I'm in green. I'm happy there. But it was 2.7 seconds when it started loading, and because I was having things that were blocking. So it was taking 3.8 seconds, which is faster than average, even though you think that it should be under 2 seconds, which I agree. It would be great if it was, but it isn't. So what it told me my critical network fail was, or not fail, but where I could improve, because it's not mean like that, it doesn't tell you that you failed, is that I was pulling in 2 Google fonts, and they were both making a request for the CSS, and then the CSS was making the request for the font. So, and then I had my own CSS, the style CSS, which was 10 kilobytes. It's actually 7 kilobytes, so I don't know why it says 10 kilobytes. But so my first thought was, you know what? I don't need Open Sans. It looks exactly like Helvetica, right? I'm not a designer, though. So what I did is I looked at the HTTP request, or the response to the request, for the first 2, those Google ones, and I just copied and pasted the response, which was a CSS call to the font file, and I put that in my CSS. So that got rid of 2 blockers, each of 600 milliseconds, which were blocking this next download of 780 milliseconds. So I got rid of one of those fonts, and what I still yet to do is I only have a certain number of characters that are in Railway. So I can actually limit the number of characters that I'm downloading. Right now I'm downloading the whole font at 10.5 kilobytes. I could probably bring that down to 2 kilobytes and make that faster. And then, since I had 7 kilobytes of CSS, I just put that in the head of the page. So these were the things that passed. I just wanted to show them to you. You know what they are. The page actually is almost all SVG, so the WebP was not an issue, but also in StartLogic, when we serve it, we automatically determine what the browser is, and we serve WebP as WebP, so I have an in on that one. Okay, and then my network payload was 160 kilobytes, which is tiny for a website, and 48% of it was that top SVG. So I could get rid of my machines, but then it wouldn't be funny anymore, so I'm not going to do that. Okay. Okay. And then, now I'm going to have to think about, oops. Okay, let's refresh. How to make it a progressive web app. So these are the requirements according to the checklist of Lighthouse and of Google to see if something is a progressive web app. There's tons of things listed here. It actually goes on for a fairly long time. So to summarize, it just basically says make your site reliable, make it fast, and make it engaging. So I decided to test my website at this point. No, I didn't. This is an old deck. I have a newer deck where I actually showed the new version of where it was at this point. And my performance is up to 92%. So the little things I did on that performance brought it up to 92%. I was pretty damn happy with that. But in terms of these things in the progressive web app checklist where I'm at 36%, most of it has to do with service workers and the manifest. So let's get out of here. The manifest. The manifest is a JSON file, and you need to have a manifest because it tells the app how to, like the website, what to look like if it is an app. So if it is an app, it's going to have the short name of MLW. So if someone were to save it on the home screen, it would say MLW instead of machinelearningworkshop.com, which would be really big on a tiny little phone. The long name is Machine Learning Workshop, which when it asks you if you want to add it to the home screen, and it says this is Machine Learning Workshop, it doesn't say do you want to add MLW to your site. The start URL is a page that when someone adds it to the home screen, this is a start URL. So normally it would just be a slash. But if you're doing metrics or something like that, you want to find out how many people actually started from your phone, so you can just add parameters. Then you need icons. So you need icons for different size phones and also for different size icons. There's going to be an icon that is going to show up when the page loads, and it's going to be in the middle of that page loading while it's waiting for its assets. And then there's going to be the one on the home, on your home page or on your home screen. And then it also asks for one that's up to 512 because we have high DPI devices that are larger. So it needs a larger icon. So going down here, the background color is when a progressive web app opens up before it gets the assets, it's basically going to paint a page for you. Oh, I forgot to put a joke in there. OK. So background color white is a really good color to choose. The theme color, I was wearing nail polish that was 226 DAA yesterday, but I chewed it off. But that's the blue of our logo. Oh, I'm a nail biter, and I'm trying to not bite my nails, so I put hideous colors on every day, and then I take them off. OK. So display can be standalone, or it can be some other. There's a few different responses to that. The thing to note is if it's standalone, it removes the UI if it ever starts on iOS. So you need to have a back button. You need to make sure that you have a back button. Orientation, you can control it if you want to. And description, yes, Machine Learning Workshop is a joke that I still find funny. OK. None of that does any good if you don't link to it in your file. So in my index page, I added link, rel, manifest, and href to the manifest file. And if you look at this is opened in a browser, you'll notice that this is an Android device. But my status at the top is a darker shade of blue than my 226D AA, but that the address bar has actually turned blue. By default, it's gray. So I controlled that, even though I'm in a web browser, and it's not actually a progressive web app yet. So let's rerun WebWhite. And I've added the manifest, but I have not added service workers yet. So my performance is at 91, which is a few things to note about Lighthouse is depending on your network, you might get a 91, you might get a 92, you might, I don't know if I'm going to go down to 90 or 90 or up to 93. Who knows? I haven't run it enough times. But basically, it's a general ballpark of where you are. Just like how long does it take for your site to load? It's a general ballpark. It depends on the network and everything else. So progressive web apps, I still need to register a service worker. Because I have not registered a service worker, I can't save anything to the cache. Therefore, I don't get a 200 when I'm offline. And the user can't be asked to install the web app because there's nothing to install because I haven't set a cache. And for some reason, I can't configure the splash screen because it says I don't have an image that's over 512. I have not figured out this bug yet. But it is a bug because I do have an image that's 512. So I did mention iOS. These are some of the stuff you want to put in for iOS, and below some of the stuff you want to put in for Windows. It's basically linking to the same images. You just need to declare the theme color slightly differently. Windows does not support service workers yet, but it's right there. It's coming like in the next build. And Safari IE6, everyone remember IE6? OK. So the next issues I have is I already told you to register the service worker and so that everything else can happen and be good. So what is a service worker? A service worker is a script that runs in the background. So it's basically on a separate thread. So all of those issues that we've been having with single-threaded, this can take care of it, but it doesn't actually have access to the DOM. It stays awake, and it is awakened. I mean, it stays on even when you're not on the website, so you can get push notifications. And it is awakened by events. So when events happen, the service worker goes, oh, I have to get busy again. So it's not like all of your service workers are active all of the time. They're basically sleeping most of the time. So I don't have time to go into everything about the service worker, but the general idea, this is the code for it, is to load a service worker, register it, install it, activate it, and then you can fetch your resources. So the one thing I didn't mention is something about progressive web apps that you want to do, which is you want an app shell architecture. So my April Fool's joke is not really a good example because it's just it's a single page app that doesn't have a second page. Progressive web apps should not be single page apps, or they can be, but they should have URLs that you can actually, like the history API, it basically needs to work. But what you want is you want the shell to always look the same. So when something is cached, the stuff that is saved is basically the shell of your page, and what you're grabbing is just new, fresh content. So you do want to build it with an app shell architecture. And now I will let you go on to your speed perception study, or our speed perception study.
Okay. That was a deep dive into progressive web apps, but let me reset. Remember, we basically said that we are interested in some sense of things loading faster than something else, and we are trying to essentially convert this perception into, something that's measurable, right? If you remember my comment that if you thought that one of them is faster and you disagreed with the majority, that you probably aren't wrong. So we did this really large-scale study because we wanted to see, does everybody really universally agree? How much is there a split? Like, is it actually as subjective as we think? So we did this large-scale study last year. There is a second version that's going on, so there is a little card.
I'm going to hand these out. If you could pass them around. It's not like we're making money off of this. I'm not like promoting any product. This is just an open source thing, and we're trying to get 6,000 to 7,000 people to take the study, which takes 3 to 5 minutes.
So, yeah, when we did the phase 1, actually, Pat put a little note on webpage test that actually drove the traffic quite a bit, and we got really good data. And the paper that we basically came up with from the results of phase 1 just got into ACM SIGCOMM Internet Quality of Experience workshop. So it's actually on archive already. But
it's here if you want it.
Yeah, that's the paper. There is some version of it that's actually in an ACM workshop this year in August. So what we are trying to do is to essentially do a bigger, larger version of it. What we did last year is actually that we took Internet Retailer 500 websites, right? Because we wanted to start with some place where it's commercially interesting. We took top 500 websites. We created a lot of pairwise comparisons. And we asked people, which one do you think is faster? And we basically didn't announce it, but what we were doing was to essentially note how long it took people to decide, okay? And it was one of these unqueued measurements where we are just trying to see how long it takes people to make a decision about which one is faster, and if they reload, we reset it. So this year, the experiment that we are doing essentially tries to calibrate like time to click, because what we learned last year was that between tablets and desktops and handheld phones, the visuomotor response timings were a little bit different, and we wanted to calibrate that better. And the second thing that we are doing is we included Alexa top 1000 along with the mobile and desktop version, so it's just a scaled up version of last year's study. So as good scientists do, before we actually did the phase 1 study, we had 3 things that we wanted to test and see. First one is that we are asking a question that's fundamentally visual, right? I'm showing you 2 videos of 2 web pages loading, and I'm asking you which one do you think is faster. So we were thinking that visual metrics would perform better than basically the non-visual synthetic metrics, and it's something you can test. The second thing we wanted to see is whether any measure, essentially any metric that's standard out there, crosses 90% in terms of explaining what majority of the people are deciding. And we wanted to see if people really wait until the visual complete, or they somewhere decide much before the visual complete. Like, when do they really know that there is enough information to decide, right? So this is the data from phase 1. It was actually fairly popular thanks to Pat and Estelle and a lot of the other people that actually evangelized it. We got more than 5,000 sessions. We had honeypots where we actually ask you to decide on things that are very obviously one way or another, and if you don't do well on it, your entire session is thrown out. So there are basically checks and balances to make sure that you're not just trying to put junk into the data. And one of the things, so this is actually some word salad of the feedback that people left. We allowed people to leave feedbacks. There are a whole bunch of people that were actually surprised that there are so many modals and pop-ups in commercial websites. So you can see that there are people who are complaining about pop-ups. I'll try. So we wanted, that observation led to us including the, do jitters actually affect performance kinds of questions, which we are actually right now planning to test. But initially, what we started out trying to do was to understand what are the elements that basically make you feel like website A is better than website B, right? But what we have come to realize at this point is that what we are going after is trying to compute some computable function that tells you what is the quality of experience. And if you think about quality of experience, it's more than speed. Speed is one element, interactivity is another element, maybe things popping up that are annoying is probably another element. So you will see a whole bunch of computer vision results that are related to computable UX from our group in future. But in terms of speed, what we saw is that actually there was a majority. So if you just took, let's say there is a pair and 100 people voted on it, you can see what is the majority vote. And if you take the majority vote about which way people chose and you try to explain all the observations about what people said, majority vote explains 75%, right? What that tells you is that there is a 25% that does not agree, right? There are people that saw different things. There was a dominant majority because 75% is better than, American elections. But so there is a dominant crowd that seems to decide one way, but it's not 100%. And there were really interesting differences between what the second minority group saw and the majority group saw. But we explored what the majority group was saying. One thing that stood out initially was that, render was actually pretty close to the majority, which is somewhat surprising. But render is the first time you see something visual, right? The closest thing is probably first paint. Render is a very WPT measurement, but something where first time you see seems to be quite important. And there were some, other metrics that we saw. But what this was initially essentially the result that we found. And remember, we were thinking that visual metrics would basically be better. And we found that visual metrics are, they're not at the top. And that was really surprising. And when we went and told Ilya and Pat Meena, people are like, I don't know what you're saying. And so we basically went back to the drawing board to see how do we make sense of this. So I'm going to switch.
Okay.
Can we go to the paper? So what we realized.
I'm backwards for yours.
Sure. Is that I just want to remind you of something. Can you see in the back the original speed index equation that I put up? Remember, if you're computing speed index, you're computing from start to the end. And end is usually maybe visual complete. But it became very clear as we were going through that the endpoint was very important to decide. Like there was this time to click where people had enough information, and if you went beyond that, it was integrating noise. So you didn't want to go all the way to the end. This is not part of the Lighthouse measurements yet, but this is actually a result we found. So there is a perceived loading point at some point in the loading space. If you stop your speed index integral there, it's actually much more accurately reflective. We didn't have that time point, so what we did is variations on PSI and SI that essentially stopped at different time points. And we had data on time to click, right? We had median time to click data for every single pair. So we created essentially variations of speed index and perceptual speed index that stopped at time to click for that pair, stopped at onload for individual pairs, and tested to see what happens. So certain interesting things come up.
It's the next page.
Right.
Okay, I'm going to zoom in on for you.
Okay.
The right one or the
right-hand
left
side.
one?
Yeah,
Okay.
the right-hand side. So the left-hand side basically
Oh,
is making a very, very simple point that, you know, these are different colors are essentially showing how many people decided before. So there are two numbers for a pair of videos, right? If there is onload 1, onload 2, did the people decide before both of them? Did they decide in between, or did they decide after both of them? And what you would see is that,
oh, sorry. Did you want to go to the next one or no?
right, I think I perceive a lot of shift.
Oh, sorry.
So, what is interesting is that the people in the beginning, so obviously nobody is deciding before both the time to first bytes, right? There is not enough information. It's also clear that no one is deciding before the render. Like, see, it's almost like nobody made the decision. But after that, it starts to switch. And the real switchover happens where essentially most people have decided, right? That point seems to happen somewhere between perceptual speed index and visual complete, right? Right now in the field, this is actually not known. There is a paper from Telefonica that came out that is trying to measure it, and it wasn't successful. We are also in the process of characterizing it. So we don't know yet what it is. Maybe it will be first meaningful paint, but it's something we are going to investigate. The second thing that I want to point out, so hypothesis 3, where we said that nobody is going to wait until end of the visual complete, obviously is true because the switch happened. Most people decided far before visual complete, right? So hypothesis 3 is true. The other thing that came up is that once we started modifying the speed index and perceptual speed index with different stopping times where essentially people had enough information, you would see that the top 5 are all visual metrics. Okay. They're not W3C measures. These are things you take a video and compute on the video. So basically what I'm saying is that if I took a video of a web page loading and I run some computer vision code, I can predict what people are going to do much better than having the entire browser API available to me. Okay. So hopefully some of these things will make it into the standard measures, but these 5 seem to be dominating. And see, onload isn't there at all. There is a huge gap. And time to first byte, which basically seems to be related to render, is still not as good. The second thing that we wanted to do is that, look, the point here that's clear is that visual metrics do seem to do better than synthetic measures, but only if you take into account when to stop, when to start, right? The second thing that basically that we became interested in is,
Oh, I don't know where you want to be.
Oh, this is my sophisticated attempt to show the stopping point thing. So if you have looked at the computes, essentially you will see that, yeah, this is the stop point. We just changed the stop point. But what I want to do is, now that you know there are different ways of computing visual measures, if you actually use them, visual metrics will perform better, but you have to use certain different measures. So code is actually on GitHub. If you go to visual metrics repository that Pat has out on WPO Foundation, you can actually do these computations on your own. So there is nothing hidden here. The hypothesis 2 that we had, which was that nobody is doing better than 90%, turned out to be true, right? Even the best, in the paper.
The paper is over here.
Okay. So the best measure that we had found, they only still go up to 80, mid-80s. They didn't actually cross 90%. So that hypothesis about no unicorn metric being present also turned out to be true. I can.
Okay.
So
I bet you can't.
I'm going to try. So my training is different. And since we found that essentially one metric didn't work, we were trying to ask, can you combine a few metrics and get better? Okay, it's a very obvious thing to think about. And I'm not going to do deep learning on it because, simple should be tried first. So we did try 2 very straightforward machine learning models. If you know them, it's like random forest and gradient boosted machines here. But essentially, we combined 3, 5, different measures and try to explain what is the majority saying. Can we explain the same thing? What's interesting, there are a couple of interesting things. See, if you use onload only, which is a very popular measure, and try to predict, you can't beat 50% of explaining people. So onload seems to really be terrible. Okay? If you use speed index, which was the big dog when I started working, you also don't seem to do that well, right? And if you take everything from your har file, like all synthetic measures from the har file, and combine them with speed index and perceptual speed index, at least the metrics that are showing up in Lighthouse, you can crack 70, but you're still not doing that well. But if you take only this modified PSI and modified speed index and render 3 numbers that are essentially visual measures, you can get up to almost 85, 87%. And it's as good as the kitchen sink, which is I am just using everything. See? So there is not a lot of gain between them. So this is interesting. So people now routinely say that there is no unicorn metric, but when we started working on this problem, people used to think, hey, this measure is better than that measure. At least we have quantitative evidence to say that isn't true. But we are also finding that there might be a small, very small set of measures. If you combine them, you could probably explain what people do reasonably well, right? It's not like 10 things. You just probably need like 3 things. And they're measurable. They can be easily computed from the little video that the webpage test gives you. If you run your, you can record a video in webpage test. If you put the webpage test video as an input, our code can essentially compute and tell you what these things are. So remember that these results are actually from IR 500 only, right? So it was just Internet Retailer 500, the guys who make a lot of money. And they were only for Chrome and desktop. And we wanted to see if these patterns hold for Alexa top 1000, or do they hold for mobile? Do they hold for other scenarios? So the phase 2, which we just handed out the cards, is essentially a bigger study that's essentially trying to look at these things. Now,
I think we need to go to the conclusion here, sorry.
That's fine.
Okay. There.
So you probably, based on the data, you can see that there is a gap, right? Even though there are lots of metrics, they don't seem to really get what we are trying to get at. So there is a gap. That we have found certain way where we can actually constructively improve towards explaining how people really seem to be making these decisions. Now, people also complained about the presence of like pop-ups or models being there. But once you make things quantifiable, and if you basically present data about where these things happen, we could probably also build models about how much does it affect perception of the people. Does it really affect people's decisions about speed? Can we go beyond just speed and actually come up with computational functions that say, okay, this felt good, like the quality of experience of a website? Some of these things might sound like science fiction, right? But 10 years ago, recognizing a face in a picture was science fiction. And this can be done. There's probably a lot of grunt work that you don't get to see. But the hope is that essentially the interface between you looking at a website on a device and a person's eyes, that interface is extremely interesting. And that interface, if you understand, we could probably build websites that actually offer really good quality of experience. Speed being an important one, but more than that.
I slipped this slide in because I just wanted to reiterate it. And that's all we have for you.
That's all we have.
Thank you so much.